I do want to do this half sheet, little practice on a half sheet this time because you're at home and you can print out whatever you want. So it's just going to be a practice sheet. The way I want to do it is I want to do one with you. So this is linked in Canvas, so you can get it from there. I want to do one with you, and then we'll have you do one on your own, and then I'll do one more with you and have you do one on your own there too. So just so you know, this is Miss Braylon's dog Lola, and then Miss Pendleton's dog Mance. And so we have this picture up from years before, but I thought we should still keep it because they're both so cute. So there's our dogs. This is who was featured in this first question right here. So what you want to do, it says the amount of time Miss Braylon's dog Lola sleeps is normally distributed, put a capital N, and this is for Lola, so I'm going to do a little L for Lola, with mean 18, standard deviation 2. Remember that notation from chapter 2, unit 1. Now Miss Pendleton's dog Mance, normally distributed, we'll use M for Mance. He sleeps 17 hours a day, standard deviation 1.5. That helps us organize everything. Assume the sleeping dogs for the two dogs are independent. Find the probability that Mance sleeps longer than Lola. So for Mance to sleep longer than Lola, we would want the probability that Mance's sleeping time minus Lola's sleeping time is positive. That means that if Mance slept 20 hours and Lola slept 18, it would be a positive number. And so we have to do this as a difference because that's the only rules we know. We have sum or difference rules. This can be written as a difference. What that means is I need to find a new mean for Mance minus Lola. I'll take Mance's mean minus Lola's mean and get -1. And a new standard deviation for Mance minus Lola. Now this formula is, we have to find their variances first. We'll do Mance's squared, always plus Lola's squared. And then 1.5 squared plus 2 squared, square rooted. Do that in my calculator. Square root that. And we get 2.5. Now we would always want to have a positive standard deviation. If we had tried to subtract those, we would have gotten an error in the calculator. So that's one reason why it's always plus. And then now we have a new normal distribution for Mance minus Lola, where the mean is -1, standard deviation is 2.5. That means that Mance sleeps an average of 1 hour less than Lola, which you can see from their two distributions, but when we combine them, that's what the negative means, because we did it in this order, Mance minus Lola. Okay, so now it's just a regular old normal curve problem, and so we're going to draw the normal curve. Our mean is -1. I need to find 0, and our standard deviation is 2.5. So to get to 0, I would go up, and it would be this rate about here. And so I find the z-score. Z equals value minus mean over standard deviation. So I'll just do 0 minus -1 is +1 over 2.5. And I get 0.4. And so remember how we do all this? We have to write capital N, 0, 1 for the z-score, our standardized curve. Oh, that's so ugly. No, I can't do it. I was going to leave it, but still ugly. Okay, can leave that one. 0.4 is right where I thought it would be, up there. And then remember, we go to table A. And I'm looking for 0.4 on table A. And so, see if I can find where my table A went off to. 0.4. I got 0.6554. Remember, table A only shows you the values to the left, so that's what this area represents. I want the shaded region, so I'll do 1 minus 0.6554 and get 0.3446 for my answer. Remember, your whole answer, though, is this whole thing. So what I want you to do now is just use this problem as a guide to do number 2. And then I'll unpause the video. You'll unpause the video to check the answer. And then we'll do number 3 together, and you'll do the same thing with number 4. All right, so here's how we did number 2. I did female minus male for female being taller than the male. And then you just have to make sure you do everything in that order, female minus male the whole time. The other people could do it male minus female and get the same answer. You just have to keep it consistent throughout the problem. And that's what you get. You can pause to look over it. And we're going to do number 3 together. Okay, so number 3, we have the weights E of a single large grade A eggs from Eggland's Best are normally distributed. So I'm going to say capital N, E, with mean 68, standard deviation 5. The weight of the carton, we'll use the letter C for that, carries the eggs are also normally distributed with mean 20, standard deviation 2. Find the mean and standard deviation for the total weight of a carton of eggs from Eggland's Best. So let's just write W equals, and at Eggland's Best, we would be adding 12 eggs together. So egg 1 plus egg 2 plus to the 12th egg plus the carton. This is a sum problem because I'm combining 12 different eggs together. I'm not taking one egg and multiplying it by 12. I'm taking 12 eggs and adding their weights together plus the carton. So it's important that I write it like this. And so mu of W, it will work out that I can do 12 times 68 plus 20. But remember, when I actually were to take 12 eggs, I would be taking 12 different eggs and adding all of their different weights together. They don't all weigh 68. We just can use that as an average. And I get 836. And so that's important for when we do our standard deviation because we want to use the formula for the variance, which means I'm going to take my standard deviation of 5, square it, and add it to itself 12 times, which is how this works out algebraically, plus 2 squared. So I'm going to be doing that in my calculator. Square root 12 times 5 squared plus 2 squared. And I get 17.4356. Now, that is not equal to 12 times 5 plus 2. So do not do that. You have to think about the variances. So we're adding 5 squared 12 times and then adding in the 2 squared because we're combining 12x plus the carton. So we have to use the rules for addition or sum, the sum rules. Okay, so what's the probability that the weight of a carton of eggs is over 850? Hold on. I was active. iPad. Okay, so the weight is over 850. And so we're going to draw a normal distribution for the weight with 836 as the mean and 17.4356 as a standard deviation. And then if I added 14, I would get to 850. So 17 will get me there past 850. So that's right here. And then I find the z-score. And so I'll do 14 divided by the answer, 0.80. And that's my z-score. So now I'll do a z-score curve. Oh, those get bad at the bottom of my iPad. 0 and then 0.8 was about where I thought it would be, right there. And we'll look on table A. For 0.8, it's 0.7881. And so I have to do 1 minus since that's on the wrong side. And I get 0.2119. All right, so now you guys try the last one. It's another one similar to this. So try number 4 on your own, and you can pause the video while you do it and then unpause to check the answer. All right, here you go. We're adding together 30 songs. Remember, each song will have its own different length, and so we're adding 30 variables together instead of taking one and multiplying it by 30. So we have to use the sum rules for that instead. And please email your teacher if you have any questions. Hopefully this clicked. If not, we'll keep practicing. Have a great day.